So we'll be trying to provide solution to the assignment given. So mathematics for computer vision. So this is like if you look at the assignment, this is notebook. So you can actually use Jupyter Notebook or you use your Google Colab. So Google Colab is easy to actually use and you can easily access it. So to do this, they gave us that we should compute the gradients of this. For those of us that are familiar with gradient, we also know that it means slope. You understand? This is like in mathematics, calculus, mathematics. So now, for us to do this, the first thing we do is to create a new. So we are going to create a new a new Google Colab, like a new notebook. So now from our file, we've created a new notebook. Now the first thing is to name the file according to what was told, what you were asked to name it. So let's check. Okay, this is assignment submission. So this is the pattern, the way they want you to name the file. So I'm going to copy this. So this is how they want you to name the file. So we have these two calls. The first one now. So we go and then let's copy this. So the only thing I'm changing is my fellow ID, which this is my fellow ID. I'm just going to copy this and then change this. Now, I've successfully created my file. Now, to solve this question, the first thing I do is to import my library. In this case, the mathematics library that we are using is SimPy. So the SimPy, I can say, okay, I don't want to be using SimPy always in my code. So let it be as, so anywhere instead of using SimPy, I use SP for SimPy. So the next thing is to declare a variable X. I'm declaring a variable X, and the way you do it is to say, okay, this SimPy should declare a symbol, then I put the X in bracket. Now when I run this, it will not show you anything, but you will not see anything when I run it. So the next thing is to actually put a function. Let this Jupyter notebook know that, okay, this is the function we are working with. So we can say F for function. So we are working with from the question. Let's go back to the question. From the question we have that, okay, sorry, okay, this is f of x, our function of x. This is the formula, the question for f of x. So I'll go back to my Jupyter notebook and paste this. Now Python doesn't know what all these signs is. So to be safe, what I will do is to select anywhere I see this. It's supposed to be raised to the power, so I'm going to replace it with double. So you just hold your shift D and copy, then you put your sign, hold shift and then add the sign. Now I've done this. Then in between this, I'm going to put my x sign, multiplication, and this is it. So if I run this now, you see that it is okay. It knows what this is, what this code means. Now Now that I've done this, the main thing for me to do now is to find my gradient. I want to know what my gradient is. And how do I find my gradient? I have to write the code for the gradient. And the code for the gradient will be, I can say gradient is equals to sp, that's your math library dot difference. Then I put my f, then my x. So it knows that this is what I'm using for gradient. I'm going to use the function f of x. Now to calculate this gradient, I have to put the formula value to calculate the gradient at, let's say at 3, value at 3 or gradient at 3. All I just need to say is gradient, then I do this. Now that I do this, it's going to calculate the gradient at when x is 3. So if I run this, it's not going to show you what the gradient is unless if I want to print the gradient. So I can say, okay, now let me print the gradient at this point. So I can just write print, Python coding. So gradient, okay, let me write the formula so that you see the formula. Gradient formula is supposed to be inside there. Cut gradient formula, then it should show the formula for me. Gradient. So the formula, this is it for gradient. Then the next part is for it to print. Sorry, it's an error in my code, comma. So I want to do the same thing, but now I want it, instead of gradient, it should be the gradient value. Gradient value at when x is 3. So now it should print what? The gradient at that value. So what did we use as the gradient at that value? At 3, this is it. So we just copy and paste this here. So Ctrl V and let's run this. So successfully gotten the answer for our gradient at when x is equals to 3, 279. So we have successfully answered this question. Now to submit our answer to this question, going back to now, if you look at this, when we look at our, they said, please note that please note that you are not to upload your notebook. You have to submit the answer as a response in the assignment submission form. So you are not to submit the code. All you just need is the answer as a response. So now to submit the answer as a response, you go back to pardon. So you go back to the class and now see you have to submit the answer as response. So normally so this is it. This is the foundation, this is your course, but the submission link now is what we are looking for. So submission link now. So just open this. Okay. So this is the assignment submission link. You can see they are color coded. the first assignment, which is this now. You click on this. Sorry. Click on this. So come on. So let's load it again. I don't know how where is it taking me to? Okay, this is it. This is where we are supposed to. So all we just need is the answer. We are not submitting the notebook for the first assignment. So for our answer from our notebook now, you can just copy that, copy this, Ctrl C, Ctrl C, copied it, go back to the submission form, and this is your answer for question. So you can just put the gradient value, not necessary that you write. So your answer is gradient value is what you are looking for. Gradient value at 3:9. So you can add your email, some so DeepTech fellow ID like I used here. So I'm just going to copy this, come back here and paste my fellow ID. So I've done assignment 1. So I hope we all get how to do the assignment. Guys, so to answer question number 2, under mathematics for computer vision. Now they say use uniform distribution. From what I understand about uniform distribution around rand permutation is that we should create a random value of equal chances. That's from the question. Now to address this question, we have to now go to let's go to this. We have to come to our Jupyter notebook. The first thing now to do is to import our library. And what does this library help us to do? Our library is touch. Our touch library is what helps us with this permutation, because we are dealing with permutation. So now that we've imported this part library, we define a function. We define this and then tell it that okay, we are taking this variable a, b, c. Now a, b, c, this define the arrangement, and this is like the range of the value, the highest value in our range, because it says 0 to c. So now that we've done this, we have to create a variable for total element in this tensor. So total element in the tensor, we can tell it that is for us to get it, we say multiplication of a times b to get the total element required in this function. Now, for us to know the total permutation, so we can say total of permutated value, permutated underscore value. Permutated value, we can say okay, the touch times touch dot random perm, then control sorry, touch the random perm. Then what I'm going to say, okay, my c plus my 1 plus 1. So this is what is creating the random permutation. Then I can now say, okay, total underscore element. En. So now they are the same. So this is meant to create random permutation for us. I just hope it works. Then now that we've created the random permutation, the next thing we do is to return the permutated value so that the user can see the permutated value. Then we reshape it so that it comes out, because if we just return permutated value without reshaping it, reshape it in the form of a comma b. So this is it. We return the permutated value and we reshaped it. Now that we've done this, let's run this code. Okay, it's saying we need this here. So I really don't know what the error is, but let me tell you to explain error. If you can explain the error to me. We said the error message expected an indented block after the function. Customs function is not properly indented. Oh, sorry, I've forgotten writing a Python code. So indentation is actually the issue. I think this should work. So it's just, so it's actually sensitive to indentation. So I think that's the main issue of the code. So now that we've done this, we can now go back. Okay, they say we should try this custom function. Try this. This is the part 2 of the question. So let me come back to my Jupyter notebook and then do this. So I can actually comment this as part 2 and I'll add a comment to this as 1. So let's see. So we've been able to get this. So this is our part 2 of the question. So I copy this, I come here and I add this. Now going back to our computer vision, let's see. If you look, this is submit your assignment 1 answer, then upload your assignment 2 notebook. You are now uploading notebook. This is for course 1, submission for course 1, computer vision, mathematics for computer vision. So what we'll do now is to now go back so if you look properly here, for course 1 computer vision, they all bear the same course code. So both assignment 1 and 2, so there's no need changing anything. The only thing now we are changing we are doing now. Now that we've gotten this, we have to save this. Let's see, save. Okay, no, so not save. Download this. Downloading this. Week 3. Come back to my submission, and then I add this week 3. Week 3. So I have successfully submitted week 3 course 1 assignment, computer mathematics of computer vision. Submit it.